So in this module, we're going to be playing with servo motor. Servo motors are tons of fun. They're like little tiny robots that live in a box. And we're also going to play around a little bit with doing mechanical interfaces with cardboard, because it's a great thing to prototype with. So before we get going on this, I am assuming that you completed the Quick Start module. If you haven't done the Quick Start module, go back and do that one first. I'm also assuming you have some kind of cardboard thing you want to interface with the servo motor. Like, I don't know, a simple primitive robotic arm, like maybe a piece of cardboard. Or if you're feeling really fancy, maybe you went and built a little, maybe you built out some fancy mechanical linkage or something like that. Like this one I made that converts a rotation motion into kind of like a cardboard robot punch motion. Whatever you have, some way to kind of zip tie to a servo motor. We'll be doing the simple stick one for this case. For attaching, of course, zip ties. Zip ties are great for everything. You're going to need a mini servo or a bigger servo if you want. And as long as you have less than 2 or 3 servos on your robot, these mini servos don't draw much power. We can actually power them straight off of the pins on the Arduino. You're also going to need some way to interface. Like they have a little screw and a little flapper thing. If you are screwing it together, if you pulled it out of the box and you're screwing it together, usually I use the non-wheel, the little single poker thing version. I don't know if there's a word for that. There's a few different things you can attach to it. And there's a few different screws. You want the screw that's not pointy. That's how you're going to attach components to the servo motor, to the servo's main gear. Oh, and of course, as with all of these modules, you're going to need some jumper wires to wire stuff up. So have some handy. So let's go ahead and get involved. First, we're going to do the mechanical part. We're working our way from the bottom up, just like the rest of those modules. So we're going to attach our primitive cardboard robot arm to our servo. I've already cut a couple slits in it and put a zip tie on it. And then I punched a hole with a hole punch so that I can like slide the little thingy onto it. And this tends to work surprisingly well for attaching that. Also, you'll notice that the servo motor has a 180-degree sweep if you're using a regular one, not a continuous or something like that. A standard servo has about a 180-degree sweep. So you want to carefully, gradually move it back and forth to find its boundaries. And you want to kind of line it up. So generally what you want is that the middle state is pointing away from it because it just makes it easier to mount. That's what we'll be doing for this case. We're going to go ahead and do that. We're going to attach this, drop a screw into there. Whoop. And I'm blocking everything, but I'm just screwing the little thing down. So now it moves back and forth. Oh, the cardboard, yeah, you don't want to move that too much because it's not great for the servo. Then we're going to go back to Johnny 5, and we're not going to look at H-bridge anymore. That's from a different section. We're going to go find servo, and there's a bunch of different kinds of servos and a bunch of different kinds of servo controllers and stuff like that. We're just going to go regular, plain old boring servo, because that's what we have handy right here. And you'll notice the servo has 3 pins. They're black, red, and white on this one. But on this one, the orange pin is equivalent to the white. The red pin is equivalent to red, and the black pin is equivalent to brown. I'm pretty sure. We'll find out if it works. So let's go ahead and copy that schematic over. So we're going to go back to our Hello World Quick Start board. We're going to grab a few different wires. And we're going to just wire it up. So I'll even grab black, white, and red wires so that it generally matches what's going on there. I'll grab a green wire. Use the green for the signal. We're going to go ahead and we're just going to jam some wires into the little connector here. So orange is green now, and the green wire, their signal wire goes to any pulse width modulation. See the tilde here? We need to make sure that we do that. So it needs to go to one that has pulse width modulation output. On my board, they're represented by dots. So pin 10. The third one up that connector. And then we need power to go to it. So we can just take that from the voltage line we have right here from above our button. And try not to let these touch. This is kind of sloppy, but it will definitely work for now. We'll just hope it does not get shaken out. We'll use another green wire because I only cut a few things of this length. Cut another color. And we're going to connect that to ground, which we have down here next to our LED and pull down resistor. We're going to jiggle those and make sure they're in pretty good. We're going to bring our servo back into view. And then we're going to do the same thing we always do. We're going to copy the source code down here. We're going to initialize our servo on pin 10. So we're going to go back to our source code here. Create a servo. We're going to add it to the REPL, which will be really useful for the servo because we're going to kind of tinker with it in source code. And then these are all commented out. Sweep just goes back and forth. So let's just get servo.min and servo.max because we have that button. We'll take advantage of that. So when you press the button down, we'll go to servo.min. And when we let the button go, we'll go to servo.max. And this should go back and forth. Like it should do a manual sweep for us when we press the button. So let's see if I got the pin right. Let's go ahead and, oh wait, I didn't plug the board in. So I'm gonna plug in my board. I'm gonna see it twitch as it gets power. And then we're gonna go turn that on. So now, when we, oops, it's kind of strong. So when we press the, oops, when we press the button down, it goes out to the maximum position, and when we let go, it goes to the minimum position. We can also use the REPL to communicate with that servo as well, because it's in there as servo. Servo dot, and if we just want to go to a specific location, which is between 0 and 180 degrees, we can do that. So what is that? It's just probably servo dot 2, servo dot 2, like servo dot 290. Just run that. Servo 291, 95. You can see it kind of move a little bit. And servos are kind of like tiny little robots on themselves. What's kind of cool is if you were to force it to move, it'll move back to the position that you have programmed in. Like this is not good for the servo either, so you don't want to do this a lot. But if there is an event in real life that causes it to move around, it'll try and get back to that position you gave it. Boop. And like they move pretty fast. There's a whole bunch of different configuration parameters you can pass in to change its speed, to do calibration, stuff like that. But we don't. You can tinker around with that outside of this module, because with that, this module is actually already done. This is a pretty short one. Servo motors are incredibly powerful and also really easy to hook up. So if you want to keep hacking, go ahead and go find another module, or just start hacking away on some other component that is not listed here.